GATE 2020 Metallurgical Engineering Question 43. Iron is corroding in fresh water which has dissolved oxygen concentration of 15 millimole. The anodic current density at an over potential of 120 millivolt is given that anodic Tafel slope is 0.06 volt. Diffusion coefficient of oxygen is 2.42 into 10 raised to power minus 5 centimeter square per second. Diffusion layer thickness is 0.06 centimeter. Okay, I'm going to use the concept of concentration over potential in this problem, and as the Tafel slope is given to be 0.06, the Tafel equation for anode is where that is anodic over potential in volts, beta is Tafel slope again in volts, IA is anodic current density in ampere per centimeter square, I naught is exchange current density in ampere per centimeter square. Fine. So first of all, let us look at the reduction and oxidation reaction that are taking place in this system. So at anode, iron is getting oxidized to iron ions plus 2 electrons, while on cathode the oxygen and hydrogen ions are getting reduced to hydrogen, H2O, that is water, that is ORR, oxygen reduction reaction. Okay, so here we have to balance the number of electrons, since in reduction reaction there are 4 electrons taking part, while in oxidation there are only 2 electrons taking part. So to achieve a balance between the number of electrons, we have to multiply the oxidation reaction with 2. So that will be 4. Okay, here this is anode and this is cathode. Okay, now here we have to determine the limiting current density, okay, that is represented by IL. Okay, so the limiting current density is given by this expression, where D is the diffusion coefficient, N is the number of electrons taking part in the system, F is Faraday's constant, Cb is concentration of ions, where X is your diffusion layer thickness. Okay, since all these parameters are given in the problem, so I am going to straight away apply the values and determine the limiting current density. Okay, so IL will be, now what is the diffusion coefficient? It is 2.42 into 10 raised to power minus 5. Number of electrons taking part are 4. Your Faraday's constant values is constant 96500 into, now the concentration of ions, it is given to be 15 millimole and mole is given in represented in terms of liter, so I have to convert liter into centimeter cube, and 1 liter is 10 raised to power 3 centimeter cube. Okay, since all the values are in terms of centimeter, so I am going to determine the concentration also in terms of centimeter cube. Okay, so it will be 15 millimole. So milli means 10 raised to power 3 mole per centimeter cube means 10 raised to power 3 centimeter cube. Okay, divided by, now what is the diffusion layer thickness given? It is given to be 0.06 centimeter. Fine. So upon calculating, you will find that IL value is nothing but 10 raised to power minus 3 ampere per centimeter square. Okay, that is the limiting current density. Fine. So I am going to replace the exchange current density with limiting current density, okay, to find the anodic current density. Okay, so in this expression, that is over potential is beta log of IA upon I naught. I am going to replace I naught with IL and determine the value of anodic current density. Hence, over potential, it is given to be 120 millivolt. So it is 120 into 10 raised to power minus 3 volt. The Tefel slope is given to be 0.06 volt. Log of IA upon IL. What is IL? IL is 2.33 into 10 raised to power minus 3. Fine. So upon further simplifying it, it will be log of IA upon 2.33 10 raised to power minus 3. Okay. So taking log on the other side, 10 raised to power 2 is IA into 2.33 into 10 raised to power minus 3, or IA comes out to be 2.33 into 10 raised to power minus 1. So IA is 0.233 ampere per centimeter square. Okay, so that is your correct answer. So your correct answer is 0.233 ampere per centimeter square. Now to know more about the concentration over potential and the Tefel equations, you can refer the week 7 lecture 34-35 of corrosion part 1 by Professor Kalol Mondal, Department of Material Science and Engineering, IIT Kanpur.